Mock exams aren't far away, so let's try a question a day. So we got this question here, and it's a pretty standard question in the sense that we need to find what R is by finding the magnitude of the 2 and the 1.5, and then we need to find what A is and alpha is, and that's what we're going to do. Okay, so I'll show you what I did. So what I did is I used the addition formula for sine, and that tells me that the sine theta minus alpha of an angle can be written as sine theta cos alpha, and then minus sine alpha cos theta, okay? And then obviously we got the r, which is going to be multiplied to both of them. And then we can write r cos alpha equals 2 and minus r sine alpha equals 1.5. So we can divide the r sine alpha by the r cos alpha, which gives us tan alpha equals 1.5 over 2, and tan alpha is equal to 3 over 4. And you might be wondering where did the negative go. Well, the r sine alpha is equal to the minus 1.5, and really I should have written that a bit more clearly, because technically that's a mistake. Yeah, so now I can say, therefore, r sine alpha is equal to 1.5. Okay, now I can say that. And then tan alpha equals 3 over 4, so alpha equals 0.6435. And then r, as I said, is the magnitude of 1.5 and 2, so it's 2.5. B, let's go on to part B now. We need to find the depth of the water at 0 hours. And if we look at this function right here, this function is exactly the same as this one. The only difference is 6 has been added to it, and then the theta has now become 4 pi t over 25. So we know how to write this in this r sine form, and you're not told what this is because this is how common this question is. It's so common. They're expecting you to know how to do part A. If you can't do part A, you actually can't do any of the rest of these questions. So you need to know how to do part A, and correctly as well, because otherwise you're carrying the error forward. So what we're going to do is 6 at 2.5 sine 4 pi t over 25 and minus 0.6435. And then if we let that equal 0, we get 4.5. Okay, as our starting depth, because that's when time is 0. Now the maximum depth, we need to think of the function of sine. The function of sine is maximized at 1. So using that, this form, this harmonic identity, we have 6.6 at 2.5, which gives us 8.5 meters, and that's the maximum depth. Okay, now we need to figure out the time it occurs. So there's 2 times where sine is maximized, well, more than 2 actually, but in this case we're only interested in 2. 1 pi over 2, and the next one 5 pi over 2. And the reason that is because the question has asked us the time in the afternoon. So if we figure out what at pi over 2, what the time would be, we'd get 4.4 hours. And this will still be the morning because they're measuring at 12 p.m. So we need to 12 a.m. sorry. So we need to calculate again at 5 pi over 2 to get the afternoon time. And that's 16.905 hours after 12 a.m. So this will be 4:54 in the afternoon if we convert it all to hours and minutes. Now, there was a typo in this question, and actually this should be 5.22. And I think this is why you cannot find this paper online anymore, because they messed it up. So essentially, Jolene is using 5.22 at 2 sine 4 pi x over 25 minus 1.5 cos 4 pi x over 25. So if you substitute 0 into that, you'll get 3.74. or 3.72, which is not equal to 4.5. So to improve the model for Jolene, what we will do is we'll consider the fact that Jolene didn't consider the 24-hour delay. So she's recorded the depth 24 hours after Tom. So if we get Tom's model and add 24 hours, that would make this work. So something like that. If we just consider the 24-hour delay between them, Tom's model could be adjusted, or you could adjust Jolene's model, but a suitable comment like that would get you the mark. So I hope this video has made sense, and I'll see you in the next one. Peace.